Imagine flying thousands of miles across oceans without stopping once to rest. It sounds impossible, right? Yet some birds seem to pull off this extraordinary feat. Scientists have long wondered if birds can actually sleep while flying. The very idea feels like something out of a dream. But recent research has uncovered surprising truths about how birds survive these grueling journeys. Most animals need to stop and rest when they sleep. Even humans can only push themselves for so long before exhaustion forces them to shut down. But birds like the frigatebird can spend weeks soaring over the ocean without landing. How can they possibly survive such long journeys without collapsing from fatigue? The answer might lie in one of nature's most fascinating survival tricks. Scientists discovered that some birds engage in what's called unihemispheric slow-wave sleep. This means only half of their brain shuts down at a time while the other half stays awake. With one eye open and one half of the brain alert, they can rest without losing awareness of their surroundings. It's like having the power to nap and stay vigilant at the same time. This type of sleep is not unique to birds, it's also found in dolphins and seals. For birds, it allows them to stay airborne and avoid predators while still getting some rest. Imagine sleeping through the night while keeping one hand on the steering wheel. That's essentially what these birds do during migration. The most famous example comes from frigatebirds. These seabirds can fly for up to 10 days straight over open oceans. Researchers fitted them with brain monitors and discovered they do, in fact, sleep while flying. Astonishingly, they only get about 45 minutes of true rest per day, split into tiny naps. Yet they manage to function perfectly well. Frigatebirds rely on air currents and thermals to glide, reducing the need for constant wing flapping. While gliding, they let part of their brain rest. This is the key to conserving energy while still staying in control of their flight path. Without this adaptation, their marathon journeys would be impossible. Swifts are another bird with remarkable endurance. Some swifts spend up to 10 months in the air, only landing to breed. Scientists believe they use a similar half-brain sleeping method, though studying them in the wild is much harder. If true, swifts would hold the record for the longest time any bird spends without landing. Not all birds can sleep in flight, though. Most species, like pigeons and sparrows, need to perch to rest properly. This makes migratory journeys much more dangerous for them, as they must find safe resting spots along the way. Those unable to land on water, like many songbirds, face enormous risks when crossing oceans. Birds that do sleep while flying face a delicate balance. Sleep too deeply, and they risk losing control. Stay awake too long, and they risk exhaustion. Unihemispheric sleep is nature's perfect compromise without completely letting go. It's one of the most incredible biological hacks evolution has produced. One fascinating discovery is that birds can even enter REM sleep while flying. REM sleep is the stage where dreaming occurs in humans. Scientists recorded frigatebirds experiencing brief bursts of REM mid-flight. Imagine a bird soaring over the ocean while dreaming at the same time, proof that sleep is as vital for them as it is for us. You might wonder, doesn't sleeping in the air make them vulnerable to predators? Surprisingly, the answer is no. Birds like frigatebirds soar at such high altitudes sometimes, over 3,000 meters, that predators are rarely a threat. By the time they come down, they are already rested enough to stay alert. The ability to sleep while flying is not just about surviving long migrations. It also gives these birds an advantage in environments where landing is risky. For seabirds, landing on the water can make them easy prey for sharks or large fish. Staying in the air while resting is the safer choice. Compared to humans, the difference is staggering. We need 7 to 8 hours of sleep daily to function properly. A frigatebird, on the other hand, can operate with less than 1 hour of fragmented sleep. Their brains are uniquely adapted to survive with far less rest than most animals could handle. But this adaptation comes with trade-offs. Studies show that after returning from long flights, frigatebirds sleep much longer than usual. It's like their bodies are making up for lost rest. Even nature cannot cheat sleep forever, can only delay it. These findings have raised fascinating questions for scientists studying sleep. Could humans ever learn to use unihemispheric sleep? If so, we might be able to rest without fully shutting down like birds do. While it sounds futuristic, studying animals like birds and dolphins gives us a glimpse of what might one day be possible. The ability to sleep in flight also shows how deeply migration has shaped bird evolution. Without this adaptation, species like swifts and frigatebirds could never travel the vast distances they do. Their survival depends not just on strong wings, but also on this remarkable neurological trick. It also highlights how different sleep can look across the animal kingdom. We often think of sleep as lying down and closing our eyes. But in birds, it's something far more flexible and complex. Nature bends the rules when survival demands it. Some researchers even believe that studying these birds could help humans better understand sleep disorders. If we can figure out how birds rest in such extreme conditions, we might uncover new treatments for insomnia or narcolepsy. Birds may hold the key to solving mysteries about our own sleep. Despite their incredible ability, not all birds rely heavily on in-flight sleep. For many species, finding a safe perch remains essential. But the fact that some can literally nap on the wing shows just how inventive evolution can be. Birds are not only masters of the sky, they're masters of survival. So, do birds sleep while flying? The answer is yes, but not like we do. Gap, with half a brain, catching tiny moments of rest as they soar across endless skies. It's a survival strategy that allows them to achieve one of nature's most awe-inspiring feats: flying for days, weeks, or even months without touching the ground.